We are doing 9-3 parabolas, and there are two different types of parabolas. There are the ones that you're used to seeing from chapter 7, where if your A is positive, it opens up. If your A is negative, it opens down. And if you realize, it's the same exact equation from chapter 7. The only new things that we've added here are your focus point, which I'm going to add a little C here, and a directrix, which is the line back here, okay, and that is a y equals line because it's cutting through the y-axis. So when you're asked to identify the equation of the line, you're going to say it's y equals wherever it crosses. Sometimes you're going to need to know the distance between your focus and your vertex, and that is a distance of C. It is the same distance from your vertex to your directrix. It's also C. So from focus to vertex is the same distance from vertex to this line, which is your directrix. And you use that sometimes to help you find A depending on what you're looking for. Because if you notice, you have a C here, and that's how you can find what A is in this equation. Your vertex is still H, K, and nothing else has changed on that one. Make sure you write everything down on this page, so if you need to pause it, please do. Now this is a little bit of a different type of equation, and if you notice, your parabola is to the right here. And it could also be to the left, depending on whether or not A is positive or negative. Okay? So if A is positive, it's going to go to the right because these are positive numbers. It's in the positive direction. If A is ever negative, it's to the left, and again, that would be all the negative numbers along this side. Your vertex is still H, K, and you have a focus as well. It's from your vertex to your focus is a distance of C. That distance is the same from the focus to this line, which is the directrix. The directrix in this case is going to be x equals because it's cutting through the x-axis. And wherever it cuts through, it'll be x equals that particular number. You still have the same equation, A equals 1 over 4c, and you can use C to find what A is at times when you need to. Sometimes you're going to use A to find C, so it goes both ways. So make sure you write all this down, and we'll do an example using the two drawings above. I could tell you that you have a vertex at -5, 1, and a directrix at y equals -2. So we can go ahead and graph that. We know we have -5, 1. This is your vertex. Your directrix is cutting through the y at -2. So 1, 2. And I make it a dotted line so I don't mix it up with my x-axis or y-axis. So again, this is y equals -2. And if you notice, when you look at your parabolas here, your parabolas are never going to cross into the directrix, ever. So even when you have one like this, you can't have it frowning if your directrix is back here and your vertex is up here. So you will know that this one has to open up, this particular parabola, because it can't be left to right because that would cut into the directrix, and it can't be down because that would also cut into the directrix. So you for sure know that we are looking at the equation y minus k equals a x minus h squared, because this is a parabola. Now if it's asking you to write an equation and it only gives you this particular two things of information, let's plug in what we know. We know that our h for our vertex, we know was -5, and we know that our k is 1. So we can plug that in to this guy right here. I'll have y minus 1 equals, we don't know what a is yet, x, and it's minus -5, so it's really going to be a +5, right? It's opposite of what we think, squared. So the only thing we're missing is our a. So if you remember, we have a equals 1 over 4c. And we know that the distance from your vertex to your directrix is c. So we can figure out what that is. That's a distance of 1, 2, 3. So c equals 3. Which also means if we needed to plot where the focus was, that we are up 1, 2, 3 right here, and this would be our focus point, because remember, from here to here is the same distance from here to here. So let's plug in 3 for c, and our a is 1/12. So I'm going to have y minus 1 equals 1/12 x plus 5 squared. And that is the equation of our parabola. Given the vertex and the directrix, we were able to find it. Example number 2. Sometimes I might give you the focus and the directrix. I'm going to abbreviate. And I'll ask you to find an equation. For me, it's easier if you just start to graph it so you can see what you know and what you don't know. So let's plot everything that it gives us here. I'm going to plot my focus at 0, -2. So I'm going to have the focus right here. And I know that my directrix is at x equals 3, so you're going to cut through the x-axis at 3. And I don't know where my vertex is, but I know that it has to be in between the focus and the directrix, because if we go and look here at some of our graphs, remember, from the vertex to the focus is the same distance, so it has, and it's the same distance from here to here, so it has to be in the middle. So let's find out what that middle point would be. We have a distance of 3, 1, 2, 3, from the focus to the directrix. So half of 3 is 1.5, so you're over 1.5, and your vertex lines up with your focus. Okay, it's on the same line this way. Okay, so they're always going to be together. If you should know that, for one, that your parabola can't cross into the directrix, so it must be facing this way. Plus, we know that because the focus is always inside the parabola. So if you look back here at all of them, they're always inside each of those parabolas, no matter what. Okay. So now let's write what we know. If this is 1.5, because you're over 1.5, so that's 3 halves. And you're down 1, 2, because you're focused, right? This was at -2. So -2. So this is our h and k. So our h is 3 halves, and our k is -2. So we're going to plug that into our formula. And we know that we're looking at this formula because it's a left to right parabola. In this case, it's a left one for sure. Okay, so we always have an x, and it's going to be -3 halves equals, we don't know what a is yet, y minus -2 is really +2 squared. I know that my a is for sure going to be negative, so don't forget that you're going to have a negative a, and the reason is because it's facing to the left and those are heading towards negative numbers. We're going to use 1 over 4c to find out what a is, and if you remember, c is the distance from here to here, or from here to here, so that was the distance of 1 1/2. So that's c equals 3 halves, so we'll have 3 halves. So you have 1 over 4 times 3 halves is 6. So we have a is 1/6, so x minus 3 over 2 equals negative 1/6, because we know it's negative because it's facing this way, y plus 2 squared. And that is the answer to our equation of a parabola. Example number 3. It is going to ask you to complete the square to find the equation of the parabola. And it'll give you y squared minus 12x minus 2y plus 25 equals 0. So this is the equation of a parabola, but we don't have it in graphing form. So if we wanted to graph it, we wouldn't be able to. So let's get it in graphing form so we can see what it looks like. This is just like what we did before, where you're going to complete the square like we did with circles, except for if you notice, we only have one thing that's squared. So if you're trying to identify whether it's a circle or a parabola, you know that a parabola will only have an x or a y squared. And so since it only has one, it's for sure a parabola. And we know by looking up here that if it's a y squared, it's going to be a left to right equation. So we need to get our equation in this form. So I'm going to go ahead and get my y's together and my x's together. And since we know it's going to look like one of these equations, we know that the x's and the y's need to be on opposite sides. So I'm going to go ahead and add 12x to the other side and subtract 25 to the other side. And then we're going to complete the square here, so we have y squared minus 2y plus something equals 12x minus 25. So we're going to do the b over 2 squared. So I have negative 2 over 2 squared is negative 1 squared, which is 1. So I'm going to add a 1 here, and I'm going to add a 1 here. So what you do to one side, you have to do the other. I have y squared. Well, actually, I'll go ahead and just factor this, because when we're looking at this, we can just factor it, right? So I'll have y minus 1 squared equals 12x minus, combine like terms, 24. Now, when you're looking here, I would take out this number right here, whatever it is, if it's a 12 or a 6 or whatever, we're going to take out a 12, and that means that 12 times x is 12x, and 12 times negative 2 is negative 24. And the reason I took that number out is because if you look here, I'm trying to get this a. The only thing now is that my squared part is on the wrong side, so we're just going to flip these two sides. So I'm just going to write 12x minus 2 here. I'm not changing any sides because I'm just flipping it. Y minus 1 squared. I'm not like subtracting it to the other side. I'm just like reversing it. With the reflexive property, you're allowed to do that. And so now I know that I'm so close. I got x first and I have y squared. So when we look at your equation, the only thing is that I need a with my y squared. So I'm just going to go ahead and divide by 12. And I have x minus 2 equals, there's a 1 here, 1 over 12, y minus 1 squared. And that is the equation, and it looks in the right form to graph a parabola. And remember, this would be a left, in this case, a right to the right parabola, because it's y squared, so we know it's either left to right, and a is positive, so it has to be to the right. Example number 4, I have a vertex of 4, 2, and a directrix of y equals 5. If I want to write an equation, I'm going to have to kind of draw this out to see what it looks like to help me find the missing pieces. You're over 1, 2, 3, 4, up 2, that's your vertex. Your directrix is cutting through the y-axis at 5, so 1, 2, 3, 4, 5. So that means that your parabola must open downward because it can't cut into the directrix. So we know since it's a downward parabola, we're going to have y minus k equals ax minus h squared. And this has to be a negative a because it's sad, it's frowning. So we know we have y minus our k was 2 equals, we don't know what a is, x minus 4 squared because we're plugging in the 4 for h. So we just have to find a, and we know we have 1 over 4c to do that. And we know that c is the distance from here to here, and we don't have my focus point, so we have to use this c in order to find out what a is. So if you look, that's a distance of 1, 2, 3. So I have a distance of 3. So I'm going to have 1 over 4 times 3, which is 1 over 12. And you know what? I'll just erase this and put in 1/12. Oops. And we know it's negative, so don't forget the negative sign. And this is your equation. Just for practice, if we had to find the focus, we would count up 1, 2, here would be 3, and this would be your focus point. Because remember, these are the same distance. And if you wanted to label your focus point, it would be 4, negative 1. Oops. Just for practice. Alright, last one. I know these are really long notes, but they're really important. Example number 5. It's going to give you an equation. One more time, we'll practice. And it's going to ask you to write it in graphing form. Well, you know for sure that it is a parabola because it is a y squared and there's no x squared or anything like that. So, if you remember, we get our y's together and our x's together. Well, we only have one x, so we'll leave it with the number. We know that since it's y squared, we're going to have an x minus h equals a y minus k squared problem because y is squared. So let's get the x and the 11 onto the other side. So I subtract 3x, I add 11. I'm going to go ahead and complete the square with my b over 2. So I have negative 2 over 2 is negative 1 squared, which is just 1. So I have y squared minus 2y plus 1. And since I added 1 to one side, I have to add it to this side. So I can go ahead and factor this. This is just y minus 1 squared equals negative 3x plus 12. We know that we have to have an a, so I have to take out a -3. Make sure if it's negative, you take out the -2. Whatever that number is, you're pulling it to the outside. -3 times x is -3x. -3 times -4 is +12. And this almost looks like our equation, except for we need to flip it around so that we have the y squared on the right. So I'm going to have -3 x minus 4 equals y minus 1 squared. I'm going to divide by -3 because my a needs to be over here. X minus 4 equals -1/3 y minus 1 squared. And this is the answer to your parabola in graphing form.